Okay, so let's leave the numbers pretty close to the same. Okay, and look at if we're simplifying for a cube root. Okay, this time we're looking for groups of 3 when we're dealing with the powers, okay, or perfect cubes. So let's look at the number first. Are there any perfect cube factors that you can remove from 24? 8, right? This is 8 times 3. The cube root of 8 is 2, right? What number can multiply by itself 3 times to give you 8? And that's 2. And so now when we look at what's left, there's still a factor left inside of our radical. So we have to put that factor of 3 back in our radical. So all I've done right here in these black symbols is simplified the cube root of 24. Okay, let's move to the next base, x.
How'd you get 2?
Because 8 is 2 cubed. So you want to think of 8 as, if you take the cube root of 2 cubed, right? How many groups of 2 can you remove, or how many groups of 3 can you remove from 3? 1. So it comes out as 2 to the first, which is just a value of 2.
Well, why would you put the 2 to the first?
Why?
Why didn't you put 2 to the 3?
Well, this is inside of a cube root. So really, guys, when you simplify these, let me come back up to here. When you simplify this, what you're really doing is you're breaking this down into square root of 36 times square root of x squared times square root of x squared times x times y squared times y. You see how I broke this all down into whatever the index is, groups of 2? And so the square root of 36 comes out as a 6. We have 1, 2, 3 x's, right? Because the square root of x squared just simplifies to x itself. So that comes out as x cubed. We have this 1x left inside. That's where this x comes from. Here we have 1 square root of y squared that comes out as a y. And we have this square root of y left inside. That's where this other y winds up coming. Okay. You don't have to write those out, though, every time, if you can think just in terms of the factors or groups. So here, what we could have done is we could have thought of this as the cube root of 2 cubed times the cube root of 3, right? I just factored that. Here, this index and the power, anytime the index and power are the same, the number just simplifies to the base itself. So the cube root of 2 cubed is just 2. The square root of 8 squared is 8. If the power and index are the same, they just cancel out, leaving the number or the base. Okay, so this factor of 8 times 3, the cube root of 8 comes out as a 2. And the factor of 3 stays inside the radical. When we move to the x's, how many groups of 3 can I remove from 7? 2. So that comes out as x to that power, 2. And 2 groups of 3 is 6. So when I remove 6 from 7, how many x's are left inside the radical? 1. Okay, and then how many groups of 3 can you remove from 3? That comes out as y to the first. When you remove 1 group of 3, which is 3, from 3, you're left with how many inside? None. You took them all out. And so this winds up being your simplified form. So if you were writing this as your answer online, 2x to the power of 2, y, cube root, parentheses, 3x. So this is the form that you would enter that. Because 8's a perfect cube factor. Remember, the perfect cubes are, if you're looking at perfect cubes, the values that I'm going to write here in just a moment are perfect cubes. And these are the perfect cubes that you should be aware of. So 2 cubed is 8, 27, 64, 125, 216. These are kind of the ones that will commonly be used. And so what that means is if you ever took the cube root of 8, that's equal to, again, thinking of it in terms of its power, 8 is 2 cubed. So again, we see that these are equivalent. And anytime the index and the power are the same, they just cancel, leaving that base by itself.
Would there be a question where it's like how 24x was, where you have to like split it up like
Okay, so let's say I did this. Let's say I did square root of 18 x to the fourth y to the ninth.
That'd be 9 times 2.
Yep, so in this case, you look at your index is 2. So we're looking at perfect square. So now these aren't applying. Now we're looking at 4, 9, 16, 25. We're looking at 36. We're looking at perfect squares. So what perfect square factor can you remove from 18?
2 times 9.
Yep, so it's 9 times 2. The square root of 9 comes out as a
3.
3. And then that factor of 2 is going to stay inside the radical.
So where did the other 3 go?
The other 3 from here.
'Cause if you keep
Remember, this
square-
was all square root, right? So this is like the square root of 9 times the square root of 2. What's the square root of 9?
Okay, 3.
That's where the 3 comes from.
Okay.
And then the square root of 2 stays. Okay, so how many groups of, again, look at your index. Our n value here is 2, index of 2. How many groups of 2 can we remove from 4? So that comes out as x squared. And when you remove 2 groups of 4, how many x's will be left inside? None. So you don't have to write an x at all. Okay, how many groups of 2 can you remove from 9? 4, right? So 2 groups of 4 is 8. So how many, when you remove 8 of these y's, how many are left inside the radical? Okay. And so this winds up being your simplified form. Any square root, the index is 2. Remember, if I ask you to, and again, one of the other types of questions you're going to see on this is going to be, would be something kind of like this. If I asked you to rewrite this in rational power form from this radical form, you take your base of x, your power of 3, and then whatever the index is goes in the denominator of your power. For a square root, that index is always 2. Because think about it, square, if you're taking a square root, or the nth root of a square, what number is a square? So if I gave you 5 squared, what power do you use? Square is 2. So the square root will be a 2 as your index. Jordan.